This is the big picture of the physics class that you're taking right now. Really, you're exploring two ideas in this class, and one of the ideas is conservation, and you're looking essentially at conservation of energy and momentum. So energy is conserved. You can convert one type of energy, such as potential energy, to kinetic energy, as shown in this picture. And momentum is also conserved. You'll see that when you look at elastic and inelastic collisions later in the quarter. So conservation is one of the big ideas, with energy and momentum being conserved. The other big idea you're looking at is the idea of rates of change of different quantities. These are not conserved. So the rate of change of position, for example. And there are three categories. One is 1D motion, where you essentially ignore gravity, and you have a car moving back and forth, and you represent that with displacement, velocity, acceleration, and time. And another case is where you have two-dimensional motion, where the displacement, velocity, acceleration become vectors, and you can't ignore gravity because it's operating on the motion of the object. And then the third case is where you have rotational motion, and oftentimes you ignore gravity in this case. And in rotational motion, you have rotational analogs to the translational values. So you have theta instead of displacement, instead of velocity you have omega, and instead of acceleration you have alpha, angular acceleration. So these are the rate of position change. Now the other rate of change that you've been exploring is the rate of momentum change, and you've seen this in Newton's second law, essentially, where you have translational momentum change, where the force equals the mass times acceleration, and then you have rotational. These are both sort of vector quantities, and as you can recognize the centripetal acceleration in this image of the constant velocity, circular velocity, and then later on you'll get into issues of torque and I think angular momentum. But the other rate of change that you're exploring in this class is the rate of change of energy, and that is essentially looking at power. So you have worked on a special case of energy conservation. Actually, it's not conserved. That's why I call it a special case, where you look at work, which is equal to force times the distance. And it's not conserved usually because of the frictional force that's involved. So the energy is conserved, of course, because it's either expressed as work or the heat from the friction. And the frictional force is equal to mu times the normal force, and the frictional force is always parallel to the direction of motion, and the normal force is always perpendicular. It's either static or kinetic. Let's see. So what critical skills did you have at this point? At this point, there are three skills. One is resolving and adding vectors, which, hopefully you came to physics with that ability. Another is being able to draw a free body diagram, which has a point mass and then has forces on the diagram only. The other skill you should have is being able to draw a kinematic diagram, which has a reference frame, x and y usually, and then of course your one equation, F net equals ma, and on this diagram you represent only acceleration and velocity, so no forces. So that's the course in a nutshell. I hope this helps.